Hey guys, we're going to continue our work on factoring. So just go ahead and add this to the notes that you took, I guess, yesterday. I don't have a construct of time anymore. Okay, so today we're going to do my favorite type of, well, one of my favorite types of factoring. My true favorite comes tomorrow. But one of my favorites is called trinomial factoring. So the word tri, as in like a tricycle, that means 3. So we're going to be factoring things that have 3 terms. So x squared minus 17x plus 72. So for this method to work, your a value, this should look very familiar to the standard form we've been using all unit. If your a value is 1, this method should work. Okay, so make that little note to yourself. Remember to be writing down things I say as well as what I'm writing down on the paper, or else you're just going to have a piece of paper with a bunch of numbers on it and it's not going to make any sense. So we check, is my a value 1? Yes. And then, so what I'm going to do is, a lot of people call this the X method. So I'm going to do it that way for purposes of notes. I think some of you will get to the point where you can do that in your head, so that's okay. You don't have to show me this X. But what you're going to do is, we call it the X method. You put your C value up top, so this is C, and then you put your B value up at the bottom. So it's going to be negative 17, and it's going to be B. And we want to know what are 2 things that multiply together to be 72, but they add to be negative 17. So this is where knowing your multiplication tables really comes in handy. So we want 2 things that when we multiply them together, it equals 72. And when we add them together, it's going to give us a negative 17. So for this one, I'll go ahead and do it for us. Negative 9 times negative 8. Negative 9 times negative 8, that multiplies together to be a positive 72. But when we add them together, we're going to get that negative 17. So once we find our factors that meet both of those criteria, we're pretty much done. We're just going to rewrite our factors in factored form. So we're going to have x minus 9 and x minus 8. So they're minuses because these are negative numbers. And this would be your factored form of this trinomial. Super easy, super fun. It's riveting. Let's try it again with, we have x squared plus 8x plus 15. So we'll go ahead, I'll make our x for demonstration purposes, 15 and 8. So 2 things that multiply together to be a 15, but add to be an 8. So this one's pretty easy. It's going to be 5 and 3, both positive. So then it's going to be x plus 5 times x plus 3. And that would be your answer. That's the factored form. And if you're ever unsure, you can always multiply them together and see if you got it correct. All right, take a second. Why don't you try this one? X squared plus 14x plus 45. So a lot of times when I was a student, I didn't actually learn to do it this way until I was student teaching. When I was a student, I just kind of always made a little branch under my last letter or my last number, and I was like, all right. And then I did this process in my head, but I think a lot of you will find this very, very helpful. So I highly encourage you to do it. So 45, 2 things that multiply together to be 45 are 9 and 5, and 9 plus 5 happens to also be 14. So the easiest ones are, not necessarily easiest, but the most convenient ones are when they're both the same sign. Those are super duper easy. When they're both different signs, that's when you have to kind of play it, think about your negative factors as well. So that's the long and the short of trinomial factoring. You're just looking for 2 things that multiply together to be your C, but add together to be your B. So it's a lot of trial and error and making sure we know our multiplication facts. And then once you have those, you're just rewriting them in parentheses with an X. Pretty simple. And then the other kind we have is called perfect square. Perfect square trinomial. So this is kind of very, very similar. This is not one that how do I say this? I was not familiar that this was a way to factor until way later. So this is really nice. So you all get to learn this now. But let's kind of go over it. T squared minus 14t plus 49. So this one, since our a value is 1, we could factor it like this. And we want to know, so I'll do it both ways, just kind of show you. We want to know what are two things that multiply together to be a positive 49, but multiply together to be a positive 49, but add to be a negative 14. So 49, we're going to have 7 and 7. So 7 times 7 is 49, but 7 plus 7 is positive 14. So we're going to need to make both of these negative. So we're going to have x minus 7 and x minus 7. So that wasn't too bad. But along those same lines, if we notice that our a value is a perfect square and our c value is a perfect square, we don't have to worry about what it adds up to be the middle. So we know that our t is a perfect, this should have been a t, I'm sorry. We know our t is a perfect square, and we know that 49 is a perfect square. So we're going to have our parentheses, and we're going to have t, it's going to be 7 and 7. And then whatever the sign is of your b value, that tells you what's going to go inside. So the idea of this is that it's going to save you a couple of steps once you get used to using it. But in this specific case scenario, since your a value was 1, we were able to factor it using both. So this one falls in the both category. But this one, we don't necessarily have to write it like this. We could also write it as t minus 7 squared. So let's try another one that's not so easy. So let's say we have 25n squared plus 30n plus 9. So this one, our a value is not 1, so we could not do this method. So we're going to be back to the perfect square trinomial. If it's not if both your a and your c aren't perfect squares, we're going to learn how to do that tomorrow. So we're going to look and we say, okay, 25 is perfect square, 9 is a perfect square, so we're good to go. And perfect square trinomials, both of them are going to always be the same. The thing about this one up here is they're not always the same number inside, but they are going to be with this type of factoring. So the square root of 25 is 5, square root of n squared is n, and the square root of 9 is 3. My b value is positive, and it's going to be squared. Boom, look at that. Super fast, super easy. And then lastly, let's try 81n squared plus 36n plus 4. So we don't even have to worry about the middle term on this one. We're just looking at your a and your c. So if they are perfect squares, 81 and 4, yep, we're good to go. The square root of 81n squared is going to be 9n. Square root of 4 is 2. My b value is positive. And then we're going to square it. And boom, that's your answer. So if you were to FOIL out 9n plus 2 squared, you would end up right back here. And it's crazy how this works out because you don't even have to consider the b. It's wild, super fun math things. So these two, this is very, 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 very common. This type does not go away. This is the most important type that we're going to learn how to do. This one is also important. It's really a big time saver, but there's going to be 2 ways that we can do ones like this. This is much easier than the way I'm going to show you tomorrow. So hopefully both these make sense. If you have questions, let me know. But hope you all have a great day. Reach out if you need anything.